Implicit differentiation. Example 1. Find dy dx if y cubed minus 4y squared equal to x to the fifth power plus 3x to the fourth power. Now, when we do a implicit differentiation, if you look at the equation, this is for the first time, you have, we're going to try to take the derivative of the entire equation where you involve x and y. So if you take a look at this, so we're just gonna take it. We're gonna use auto rule apply here. So when we take the first term here, y to the cube, so that becomes 3y squared. Now chain rule says take the derivative of what's inside. Inside is y, so it's just simply dy dx. Minus same thing here to the second term. So you have 8y times derivative of what's inside, which is dy dx, equal to, now to x to the fifth power term, it's when you do the power rule, is 5x to the fourth power times the derivative of inside, but derivative of inside is dx dx. Now dx dx is equal to 1. So that's why it doesn't show here. And the same thing with the last term here, so it's just 12x cubed. Now, notice we have dy dx term here. We can group them out, factor dy dx. You end up with dy dx parentheses 3y squared minus 8y. Then divide by this term on both sides. Our derivative of this equation here is 5x to the fourth power plus 12x cubed divided by 3y squared minus 8y. And that's implicit differentiation. All right, let's try another one. This time involving trigonometry here. Okay, so find the dy dx if sine y squared minus cosine x squared equal to cosine y squared plus sine x squared. All right, so let's take the derivative here. So derivative of sine equal to cosine y squared. Then in using the chain rule, take derivative of what's inside, which is, so derivative of y squared is like 2y. Then derivative of the y again, dy dx. So you do a double chain rule here. Plus, try this one again. Now cosine become negative sine, but negative become positive. So cosine x squared, take the derivative, becomes sine x squared times derivative of what's inside, which is 2x. Then derivative again, well, it's just 2 dx dx, so there's nothing there. Now equal to cosine y squared, cosine becomes negative sine y squared. Take the derivative of y squared, same thing again. That's 2y in dy dx. Plus derivative of sine is cosine x squared. Derivative of x squared is just simply 2x. Now that you're done with calculus, rest of it is just really algebra and how to simplify it. Okay, combine like terms and so on and so forth. So this is what we have. So the first thing you want to do is put dy dx on the same side. You can put everything else on the other side, because by doing so, we can factor out dy dx. Once we can factor out dy dx on the left-hand side of the equation, when you divide this on both sides, then we can solve for dy dx. Okay, here's another example. Find dy dx if 3x squared plus 5xy squared minus 4y cubed equal to 8. All right, so take the derivative of the first term, which is 6x, plus derivative of this. Now, this part 5xy squared, that's your what? That's the product rule. It's 5x times y squared. So if 5x times y squared is the product, so derivative of this will be what? 5x become 5 times y squared plus 5x times derivative of the y squared. But derivative of the y, you end up with 2y and a dy dx here. Minus, again, this is a y term, so you're going to have dy dx. So using power rule, you get 12y squared. The derivative of what's inside, the y is dy dx. Okay, again, at this point, you usually are by the first step, you're already done with calculus. Now, rest of it is just looking at the equation and try to solve for dy dx using algebra, right? So I'm simply just simplifying everything inside. So this becomes 5y squared. Combine these, multiply it out, 10xy dy dx minus 12y squared dy dx. Now we have, so we want to keep all the dy dx term on the left side, and this 6x plus 5y squared on the other side. So we're going to subtract that. Okay, then once we can factor out dy dx, you can divide the term that's left over after factoring. So this divide 10xy minus 12y squared to both sides. So dy dx for this equation is equal to negative 6x minus 5y squared over 10xy minus 12y squared. Now this question is it's the same question, except we want to find a derivative at a very specific point, in this case 2 1. Right, so let's take the derivative first. So derivative of this equation, the first one is just 6x. The second part is ay, but because it's a y term, so you end up with a dy dx, plus simply y become dy dx equal to 0. Now, just like before, we're going to factor out dy dx, then you end up with negative ay plus y. Okay, this 6x should go on the other side because all the dy dx term is on the left. We kind of put the like term together and then 6x on the other side. So dy dx is equal to negative 6x over negative ay plus 1. Now, at that point, everything is the same, except when you're done, they want you to find a derivative at a specific point when x equal to 2 and y equal to 1. So you simply plug in 2 for x, y for 1, then you get your answer. So derivative it's equal to 12/7. Okay, here's another same similar example. So you divide the derivative of, you have a quotient here, 2x minus 5y squared over 4y cubed minus x squared equal to negative x. Okay, so first thing you'll do is I'll probably cross multiply. They'll make things a lot easier than try to do a quotient rule. You can say take the derivative of this, become quotient rule, but probably easier to just do a cross multiply. Put negative x over 1 here. Then when you do cross multiply, this is what you end up with. Then from here, then we can I'm going to do distributive property first. Okay, get rid of the parentheses. Then I'm just simply taking this new equation here instead of one on top. This one looks so much easier, and then take the do an implicit differentiation on it. So 2x become a 2, 5y squared become 10y, and dy dx, what's inside, equal to, now you have a product rule here. So negative 4 times y cubed plus negative 4x times derivative of the y cubed, so which is 3y squared dy dx. Then last but not least, this very last term, derivative simply just 3x squared. Okay, now you're done with the calculus once again. Now it's just algebra. Simply try to solve for dy dx. So our goal is to multiply everything out and put dy dx on one side, which is left side in this case, and then move this 2 to the other side right here. So that's negative 2. So once we have dy dx on the left hand side, everybody else on the other side, we factor out dy dx and then we divide the remaining term. So dy dx is negative 4y cubed plus 3x squared minus 2 over 12x y squared minus 10y. Now, usually that's done. It's a generic term for dy dx, but they want you to evaluate 1 1. So we're going to take this equation, we're going to plug in 1 for y and 1 for x. So where you see all the variable, you're going to plug into 1. So our final answer is negative 3 halves.